Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at passing parameters between functions and subroutines. In the previous two videos, we covered the passing of parameters, both simple and complex, between functions and subroutines. In today's video, we're going to revisit the passing of these parameters, namely arrays, covering what you can do with the data that goes into these parameters, both before and after they are passed. So let's go and have a look at the code. During this video, we're going to be looking at these user-defined types. But first, we're going to look at passing an array from a function to another function. And we'll do this within the pbmain function. So we're first of all going to dimension a local array as a string. In this declaration, we're not declaring the size of the array. We're just giving it a name and a type. We're also going to be running a new function, which we're going to call populateArray, 4 times. So we set up a local variable called longrun, which we're going to use for our for next loop. So as you can probably guess, we're going to be passing this data array to our new populateArray function. And we want to pass it by reference. This will allow us to both dimension and populate the array in the function we are calling, before passing back that data to the pbmain function. So here is the call to our new populateArray function, passing its single parameter. When passing this parameter by reference, we only need to mention the name of the array followed by 2 brackets. This will allow our populateArray function to pick up and manipulate this array. The return from this function is either going to be a true or a false. Since we're using the inbuilt isTrue function, if this is true, we can then go ahead and work out information on the dimensioned array. However, let's jump into the populateArray function first. So here is the skeleton of our new array. We're taking in a single parameter, which in this case is our array. As you will note, the label we're putting on the array is different to the label it had in the pbmain function. However, since we're passing by reference, this is accessing the same area of memory. It can be an advantage in your application to have these names as different. So now we are inside this populateArray function. What are we going to do? The array that has been passed by reference is completely empty. It has no dimensions, it has no rows, it has no columns, and no data within them. So we're going to create 4 local variables to allow us to keep track of the number of dimensions of this array, the number of rows, the number of columns, and what the starting row number actually is. So here are those local variables. Arrays, of course, can be single-dimension or multi-dimension. In this function, we're going to create a random number of dimensions between 1 and 2. So there'll be a 50-50 chance that our array will be 2-dimensional. We're going to do the same for the number of rows, the low bounding, and the number of columns, by making use of the random function. The first parameter in the random function is the lower bounding, and the second is the high bounding. So for the number of rows, we're going to have a number of rows between 10 and 20 inclusive. If we have a 1-dimension array, then the columns variable will not be used. So we can now use a select case statement to redimension our array based on these 4 values. And here is that select case statement. If the number of dimensions has a value of 1, it is a 1-dimensional array. So we're using the redim command followed by the name of the array, and two values. We're going from the low bounding to the low bounding plus the number of rows. Arrays will start with a zero bounding if you only specify one number following the redim command. So this could be from 0 to 10 or from 5 to 10. However, it's still going to be a string array. If the number of dimensions is 2, then it will be a two-dimensional array. And we're taking the same approach here for the first dimension. And for the second dimension, we're making use of the number of columns. We're not specifying a low bound or a high bound here, just the number of columns. So if the number of columns is 5, the second dimension will be 0 to 5. And at the end of this function, we're going to return the value true. So as you can see within this function, we could get back either a 1 or a two-dimension array, and it will have a number of rows between 10 and 20. And if a two-dimensional array, it could have a number of columns. So what can we do within the PB main function to handle the data coming back, the populated and dimensioned array? Since that value coming back can either be a 1 or a two-dimension array, we need a way of determining what has come back. What is the structure of this array? So we will create a local variable, we'll call it the number of dimensions. And we're going to populate that array using the array attribute command. The array attribute command is very useful for working out what kind of structure your array actually has. If we have a look in the PowerBasic help file, we can see some details of what the return of the descriptive attributes of a given array actually are. If we look down at the bottom, this first parameter will return the number of dimensions in the array, which is exactly what we're after. So this value we will get back is either going to be 1 or 2, 1 for a single dimension array and 2 for a two-dimensional array. You can, of course, have arrays with more than 2 dimensions. But for the purposes of this video, we're only handling 2 dimensions today. So we're going to send a message to our log to say which run number we're actually doing. In this for next loop, we're going to run this section of code 4 times. So in order to print out details of our array, we're going to use another select case statement on the number of dimensions variable. And we'll use the case statement to handle either 1 or 2. So we'll handle, first of all, a single dimension array. We'll send a message out to the log to say that this array has X number of dimensions based on our number of dimensions variable. And we'll do exactly the same for the two-dimension array. So if we attempt to compile and run our code now, we'll see there are our 4 runs. So for the first 2 runs, our array has 2 dimensions. And for the second 2 runs, our array has only a single dimension. Since we're going to be making use of random numbers within our application, we really should use the randomize command to set the random number generator to a seed number which will be unique each time we run the application. We can do this quite easily by using the randomize command followed by a number. In this case, we're using the timer, which will pull back the number of seconds since midnight. This will give us a reasonably random number. So what else can we determine from this returned array? We know the number of dimensions, but we need to know what row number this starts at. As we saw in our function, the low bounding of array can start between 0 and 10. So how do we determine that within our PB main function? Well, we can do that quite easily by using the lbound command for the lower bounding and the ubound command for the upper bounding. This will handle our single-dimension arrays quite happily. For our two-dimension arrays, we'll need to work out the number of rows and the number of columns for the upper bounding and the lower bounding. And for this, the lbound and ubound commands make use of an optional parameter. For the number of rows, it's exactly as we did for the single dimension. For the number of columns, our optional parameter in this case is 2, as we're interested in the lower bounding and the upper bounding of the second dimension. If we run our application once more, we get back 4 sets of information. For the first run, it had 1 dimension and it starts at row 1 and ends at row 12. For our second run, we had 2 dimensions, which start at row 7 and ends at row 23. And the number of columns is from column 7 and ends at column 23. So using these commands, you can quite easily determine the number of dimensions within an array and their upper and lower boundings, both for rows and columns. So why would you need to use this type of functionality within your application? The function we created to populate the array could be a function which is determining information from some external source, perhaps a file or a SQL Server database. And so your application may not know beforehand what kind of information is going to be returned. It could be a simple list or a large array. So using these techniques will enable you to be quite dynamic within your code. So in the second part of this video, we're now going to make use of our user-defined type we created in the last video, UDT car. So we're first going to declare our array, dimension it as a user-defined type, in this case UDT car. We'll want to populate this array within an external function, and we'll be passing it by reference, as we have done before. Again by using byref, and then following it by the name of the array we wish to pass, and 2 brackets. So let's go and create this new function to populate our array. And here is the skeleton of our function, taking its single parameter as a by reference pointer to the user-defined type array. So as we did before, we're going to create a couple of local variables. One to keep track of the number of rows, which will be a random number, and a single variable to allow us to do a for next loop. So the number of rows is going to be a number between 5 and 10. So with this information in hand, we can now redimension our user-defined type array, in this case from the number 1 to the value returned in the rows variable. And as before, we're declaring this array as UDT car, so it's an array of user-defined types. So how should we go ahead populating this? As you saw in the last video, there are 4 elements within this user-defined type: an owner name, a color, a make, and a car type. The first 3 of these are strings, and the final element is a number. So we'll handle the colors first. This will be the colors of the cars. So we're going to dimension a single dimension local array from the values 1 to 5. And we're going to be using the array assign command to assign 5 colors to each of the elements within that array. In this case, red, blue, black, yellow, and white. For the make of the car, we're going to do exactly the same. This also will have 5 values. Next, as we need to give the owner of the car a name, we're going to use 2 separate arrays, one for the first name and one for the surname. In this video, these values are effectively hard-coded into the function. But, of course, these could be coming from external files or databases. Now we can look to populate our array. So we're going to use a for next loop here so that each row of our array is correctly populated. And we're going to use the prefix command here to save a little bit of typing and to make our code look a bit tidier. The prefix command is very useful in that it takes a string and prepends this to the beginning of the next X number of lines until it reaches the end prefix command. So we're forming up the owner name by an element from the first name array and an element from the surname array, based on random numbers between 1 and 6 for both of these. This gives us a reasonably random name. And we're going to do exactly the same for the colour, the make and the car type. Note that for the car type, in the random number, I'm using two constants. These are the values we declared at the beginning of our application in an enumeration. This helps to make your application self-documenting, in that it's obvious you're going from a 2-door to a 5-door car. So now that we've created this function, we can now look to push this information out to our log. So we're going to put in another for next loop. And in this case, we're only interested in the first 2 cars. So we can push information out by referencing the array and its element. So we can extract the owner's name by using the name of the array, the row that we are interested in, and the element within the user-defined type. So this will give us the first row and the owner's name. And we can do exactly the same for each of the other elements. Note that I'm using the trim command. As the strings within the user-defined type have a fixed length, you don't necessarily want to have all the spaces at the end of each of the elements, so the trim command will trim these down. The final element within the array is a number, and we're using the format command to turn that into a string so we can add it on to the string we're sending out to the log. So if we try running the application now, we will get at the end of our output the details of the first 2 cars, with their owner, the make, the colour and the number of doors. If we run it once more, we should have slightly different random information, which we do indeed. We now have a 4-door and a 3-door car. So we can see from this how we can easily manipulate a user-defined type in an array. So in summary, what we've done in today's short video is further handling of arrays passing to functions, allowing us to determine an array that has been redimensioned within that function and has an unknown number of rows or columns, and maybe 1 or 2 dimensions. This should give you the flexibility of handling arrays coming back from functions where the structure of the array is unclear. Hopefully you'll find these techniques and this code useful in your applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.